Hello, Algebra 2. Welcome. Welcome to QUAD2, Computations with Complex Numbers. What we're going to be talking about is something we've already seen a little bit of, and in terms of complex numbers, what it is, but also the mechanisms for our calculations we've already done before. You've seen them in middle school, a little bit in algebra. So let's go ahead and take a look at this thing. What we start with is we've got complex numbers are complex, right? They contain both a real part. I have real right in here, real part, as well as an imaginary part. Now, we've already been talking about the imaginary numbers thing. We did that in quad 1, right? When you get a square root of a negative number, you end up with an imaginary solution. Now, the whole solution is what we call a complex number, right? So let's kind of take a look at this, and we're going to do some concepts that we already know. The definition of a complex number, I'm going to call it A plus BI. Again, that I right there, that I, that's the imaginary unit. I'm try that again. Imaginary unit. And just a second ago, I said we've got two parts to this. We've got a real part and an imaginary part. Well, the real part is this A value. This is the real part. We're going to take a look at this in a second to see what it actually means. And then this BI part, this is our imaginary part. Now, we've actually already seen things that look like this. And when we were doing quad 1, we were solving with square roots. Sometimes we got answers that look something like, I don't know, -2 plus or minus 3i square root of 2. And these are complex numbers. This is our real part right here, our real part. And this would be our imaginary part. So those exist. We've seen those before. We're just going to do a little something different with it. We'll see how this kind of looks at here, right? Let me do this. Let me start out by this. I want to talk about binomials. Now, our practice and what we're completely doing overall is not going to be focused just on binomials, but these are good examples to go from. So if I was adding binomials, let's say I've got these two binomials. Again, bi meaning two, nomials meaning terms. So two terms right in there. If I'm adding these things, I need to look. I've got parentheses around something. So I need to see, do I have to distribute something through? Well, yes and no, right? If I just have parentheses, that's like having a multiple by 1 on the outside. If I do 1 times 3x, that gives me 3x. 1 times 2, that gives me 2. Oh, it doesn't change when it's multiplying by 1, right? It stays the same. Well, plus, and again, this is just, again, like 1 times that. So you could write plus -6x or minus 6x, and then minus 7, right? These things don't change. And then as I look through this, I'm going, hey, wait a second here. I can simplify some more because I've got two terms that have x's and two terms that don't, that are just numbers. This is like -3x minus 5. And that's it. That's how you add the binomials. All right. Now, adding complex numbers is kind of the same thing. And adding complex numbers here, 3 plus 2i plus -3 or plus 7i, right? If I'm just distributing a 1 through it, this is like 3 plus 2i plus -3, or just -3 plus 7i, right? It's, if I'm just distributing a 1 through, it doesn't change the things that are in the parentheses. And I'm going to combine like terms. I can still do that, right? 3 minus 3, well, that's 0. That's an interesting one. 2i plus 7i plus 9i. This is my real part. This is my imaginary part. Now, Mr. Brayman, do we really have to write the zeros? Thank you, outside person. Do we really have to write that 0 in front? No. But if you're looking to figure out the complex number part of things, if it's the real part or the imaginary part, you can. All right. So that's adding these things. The 0 plus 9i, that's our solution that we're getting for here. Subtracting seems a little bit similar, and it really is. It's just distributing something through. We're going to do a lot of distribution today, actually. If I do this, subtracting binomials, again, this is like multiplying that first binomial by a positive one, and so it doesn't change anything. This is just 5x minus 2 But that second binomial, that next thing that's in parentheses, I'm not multiplying by a positive one anymore. It says just negative. Well, it's just negative. We know that to be, that's like -1. So if I distribute a -1 through, this is like 5x minus 2. -1 times x is -x. -1 times +3 is -3. So in other words, I'm kind of changing the signs there. Now, what I also need to do, once again, is simplify my solution. I've got things with x's. 5x minus x is 4x. -2 minus 3 is -5. And that's how we would subtract the binomials. Again, when we're practicing, it's not going to look perfectly exactly all the time like this, but the concepts still work through there. Subtracting complex numbers, okay? Again, we don't have to distribute a negative through. So 2 plus 4i for that first one, but I do have to distribute the negative to 3 and minus 7i. So -1 times 3 is -3. -1 times -7 is plus 7i, 7i. Combine the like terms, -1, put your real part first, plus 11i. And if you're saying, Mr. Brayman, really? That's all there is to it? Yes and no, yes and no. So I'm going to do this problem, and we're going to do it a couple different ways. I'm going to show you a couple different ways to multiply polynomials, or in this case, binomials. So let's go ahead and do this real quick. Multiplying binomials. I have 3x minus 3 times 4x plus 1. Now you may have heard or even use or be okay with FOIL when you're multiplying binomials. Multiply the first terms and the outside terms and the inside terms and the last terms, right? That only works for binomials. So I'm going to teach you two ways today that work not just for binomials, but multiplying any polynomials, So let's go ahead. The first one I'm going to do is called the distribution method. Now you already know how to distribute because that's what you've done to get here, but we're going to do it a little bit different. I'm going to take this 3x and multiply it by that entire second binomial. So I've got 3x times 4x plus 1. And I'm going to take that -3 and also multiply it by that second binomial. -3 times 4x plus 1. So I've distributed once, and I'm going to distribute again. I have 3x times 4x, which gives me 12x squared. 3x times 1, so plus 3x. -3 times 4x minus 12x. -3 times 1 is -3. Now, I'm looking to simplify here. And when I do that, I see I've got an x squared, I've got two x terms, and I've just got a number, right? I can't combine the x squared with anything else, or just a constant with anything else, but I can combine the x terms. So I'm going to 12x squared minus 9x minus 3. Okay. Again, we call this the distributive method. Distributive. Okay. Now that I like that because I'm thinking ahead to different targets, but this also helps some people too to see it a different way. All right. To see it a different way, I'm going to kind of put a line through here. I'm going to do it a different way. I'm going to call this the box method. I'm going to take the terms I've got in the first binomial, 3x minus 3. So I'm going to split them up. So 3x and -3. Then I'm going to write the terms of my other binomial. I've got 4x and 1. And what I'm going to do is make a box. I need to multiply all these things in here. And what I'm going to put in each of these boxes is like 3x times 4x would be 12x squared, and that's what goes here. 4x times -3 is -12x. 3x times 1 is 3x. -3 times 1 is -3. Well, it's really interesting because where have I seen the terms 12x squared, -12x, 3x, and -3 other than right there? So we've already seen that. What I'm trying to tell you is it doesn't matter which way you do it, you're going to get the same answer either way. We can simplify this once again. 12x squared minus 9x minus 3, still the same answer. and we call this method the box method. Something else I want to point out real quick, when I multiply two binomials together, not complex numbers, when I multiply two binomials together, I end up with a trinomial. Tri meaning three, nomial still meaning terms, 3 terms. Keep that in mind because that's going to be interesting in just a second. I'm going to use, now that I'm moving over to multiplying complex numbers, I'm going to use the same concepts. I'm going to do the same problem 2 different ways. The first way, distribution, the distributive method. 4 times 2 minus 2i plus 3i times 2 minus 2i. And we're going to distribute again. 4 times 2 is 8. 4 times negative 2i is negative 8i. 3i times 2 is plus 6i. And 3i times negative 2i is negative 6i squared. Once again, that's got I squared, so I can't combine that with the i's. But let's see, let's simplify what I can. 8 minus 2i minus 6i squared. And I'd forgive you if you think you were done, because if you remember back, I told you for our purposes right now, we've got I being the square root of negative 1, which might be useful, which it is. We've been using that, right? But I squared is the other one I told you also might be useful. I squared, we said, was negative 1. I squared is negative 1. Box that, star that, do what you got to do so you remember that. If I squared is negative 1, we've got I squared right there. What that does, it means it's like minus 6 times negative 1. We're going to change the sign of this last term. So instead of minus 6i squared, this just becomes plus 6 because it's negative 6 times negative 1. So 8 minus 2i plus 6. Then we combine our like terms, 14 minus 2i. Ooh, that's interesting. That's interesting. It looked like we were going to get 3 terms right here. It looked like we were going to get 3 terms right here. We didn't because we had that I squared. But it looked like we were going to have 3 terms. Okay, let's go ahead and do the box method also. 4 positive 3i, 2 negative 2i. Let's build our box right in here. Going to do some multiplying. 4 times 2 is 8, which is good because I've already seen that 8 over there. 3i times 2 is 6i. Yep, had that one over there. 4 times negative 2i is negative 8i. And that was another term we had. 3i times negative 2i, negative 6i squared. Again, I squared being negative 1. Negative 6 times negative 1 is a positive 6. That's what that equals. And so let's combine the things. I've got an 8 and a positive 6 to get 14. Negative 8i, positive 2i, minus 2i. So it's interesting, right? We multiply 2 complex number as what do we end up with? Well, it's got a real part and an imaginary. We end up with another complex number. So if you multiply 2 complex numbers, the output is another complex number. Now, when we do some other multiplying stuff, we're going to do it. The practice is going to look similar, but a little bit different. It's going to take your other math skills and also put them into there too with computationals. So add, subtract, and multiply and that kind of stuff. We're not going to worry about dividing right now, but that right there, that's your target. That's what we're trying to take care of. So with that, go ahead and look at the first practice. See what you guys can come up with and ask any questions you got. Take care. Have a great day.